Good evening, everyone, and welcome to tonight's 8 p.m. webinar. The webinar is on risk to project benefits realisation and some lessons from transport. Our own branch, Dr. David Worsley, is going to be presenting tonight. So settle in. I hope you've enjoyed the weather today, and at this point, I will hand over to David.
Okay, thanks, Alan. Right, okay, so tonight's subject then is risks to project benefits realisation. So will our projects actually achieve what they're intended to in the widest sense, really, is what I'm going to talk about. And I'll be talking from my own experience in the railway industry and a bit in other modes of transport, which I did for a brief while. But hopefully you'll be able to relate some of the broad themes to whatever industry you work in, and then maybe we'll discuss some of the similarities and differences at the end in the discussion session. So let's see if I can move on to the next slide here. So for those of you who don't know me, I've worked in the railway industry now since 2002. I managed to spin out being a student for 11 years, but I had to get a proper job eventually. And I started working in quite a junior sort of assistant role at Network Rail, but risk, really project risk, was what gave me my big break in 2004. I put down there I was risk and value analyst at Network Rail for 3 years, but actually for the first 2 years I was just a risk analyst, and the value side was combined into the role later on. I was very much interested in risk because of the mathematical side of it, the probability, the statistical modelling, and I studied statistics at the Open University while I was in that job. But towards the end of that role, I got more interested in the value side. We used to run value management workshops, which is a topic I'll come back to later on. And there we were often discussing, well, what is the actual purpose of this project? What are we trying to achieve? And there was also a lot of talk about benefit to cost ratios, which again is quite mathematical. And that inspired me to move into the strategic planning function at Network Rail, who actually initiate projects in the first place and are given the task of trying to work out whether a project is worth doing, whether it is providing value for money. And while I was working in strategic planning, I got to work on some exciting stuff. Worked on High Speed 2 in the early stages, and did that for 5 years before going back to risk for another 3.5 year stint. So it was a good mix of strategy and project risk and value at Network Rail, both initiating the projects and then trying to influence them as they happened. And then after that, I had another 3.5 years working in private consultancy in WSP, which was really great. And I was able to work on other forms of transport, not just rail, and dabble in risk, as well as mainly doing the strategy and project development stuff there. And for the last 18 months, I've been in a senior position at Transport for the North, so very much looking at initiating projects and building the case for them. So it's that mix of strategy and risk which is sort of inspired me with the material I'm going to talk about today. So as I said, what really first attracted me to risk was the mathematical side of it, and the possibility of modelling how much things might cost, and working out what the mean cost of a project might be, but also confidence intervals. At Network Rail, we were always very interested in the P80, the figure that the cost figure that you would only exceed 20% of the time in the cost models that we ran on the projects, because this is what the sponsors were given authority to spend up to without having to go back to much more senior levels of management. So I was interested in the number crunching side of risk. Of course, you can do this on time duration as well if you've got tools like PertMaster and so on. But of course, that's cost and time are not everything. There's also quality, or which in some cases is substituted with function. So will this project actually achieve what it's meant to? And the project manager often has to balance cost, time, and quality, and maybe sacrifice some of them. You may have to go over time in order to actually achieve what you want to. or you may decide in order to stay within cost, you'll sacrifice some of the functions. So your triangle gets distorted over the course of a project. And even some of the most famous and recognisable and much cherished projects in the world have had this problem. So the Sydney Opera House here, I think, lots of people know that it cost almost 15 times as much as it was originally intended to, 102 million Australian dollars as opposed to 7 million, and it took over 3 times as long to build as the original schedule at 14 years. Perhaps less well known, though, is it didn't really achieve everything it was meant to. The main concert hall was supposed to be multi-purpose to be able to do traditional concerts as well as operas, where you have to have an orchestra in a pit and people walking around the stage and singing. And it was discovered that the acoustics couldn't be fixed to be able to host both. So in fact, operas are meant to be held in the secondary, smaller concert hall, but the orchestra pit there is not big enough for a full-sized orchestra, and so unfortunately you can't really actually stage a full-scale opera in the Sydney Opera House. So it took a bit of a hit on the quality as well. Now, I'm going to mainly talk about transport because that's the area I've worked in. And as you can see, transport projects include some of the biggest projects that the British government's funding at the moment. High Speed 2, here from a report from last November, they're saying it's going to come in at 55 billion. We'll come back to that later on. Heathrow expansion project. It's difficult for me, not being an airport expert, to understand how you could spend 32 billion on an airport. But there you are. That's the second biggest project that the government's funding, and then we have defence as well. Now, this talk is based on one I gave to a conference in Australia a couple of months ago, and they did want me to try to talk about all UK government projects. But when I contacted the Ministry of Defence and asked me if they'd share some of the risks that none of the defence equipment would actually work, strangely enough, they were a bit reticent about sharing that information. So, transport it's going to be. And in my career at Network Rail, I came across a number of projects which it was very easy to sort of fit into this cost, time, quality triangle in terms of deciding which were the absolute must-haves, which part of the project remit we absolutely had to stick to, and which bits could be maybe sacrificed a bit. So, for example, when there were transport improvements required for the Olympics, clearly we couldn't delay the Olympics, so time was the essence there. The transport links had to be built before the spectators were arriving, and cost was the area where they had to be flexible. I think probably High Speed 2 is also in this category. I think the aim of High Speed 2 is to have a significant reduction in rail journey times between London, Birmingham and the north, and the time scale, it has to be within a imaginable scale of time, so that some of the people working on it and hearing about it and funding it through their taxes will actually get the chance to travel on it. So putting it off to 2050 would probably not be a wise political move, and that's why they're still talking about 2033, 2034, 2035, sort of the full Y network to Manchester and Leeds being in place. The thing with that's had to be flexible on is the cost. Now, when I was originally working on it, the first estimate I saw for the whole network to Leeds and Manchester was 33 billion. Shortly after that, the estimated costs started escalating up through 70, 80 into 100 billion. But rather than just scrap the whole thing, the government has tried to get those costs back under control again and proceed within something like the original time frame. So they're talking about 55 billion now, but that's still good 2/3 up on what the original cost estimate was. There are other types of project that I'm working on where time isn't really important, and it's more getting what the function or the quality, the conformance to specification of the project at an appropriate cost. So often we do journey time improvement schemes on the railway, where you straighten out a bit of track basically, or build the embankments and maintain it to a higher standard so that trains can actually travel faster across them, and these are very much you have to squeeze them in around when other projects are happening in order to get good value for money. So they can be delayed and the benefits put off without too much trouble as a result. And finally, I've been worked on other sorts of projects where, in fact, what is done is not so much important as that a certain amount of money is spent within a time frame. So when I was in strategy at Network Rail, we had something called the Network Rail Discretionary Fund, where we just were told, well, we have £100 million to spend within a certain period, and you have to show that the things you choose to spend it on are value for money, but you have your discretion on what you spend them on. So there was flexibility about what the output was there. So I think the cost, time, quality triangle is really helpful in helping us think about what the most important things we want out of our project are. Now, as I said, I'm going to concentrate on where projects have not quite achieved what they were intended to. And thinking about all the projects I've worked on or been aware of, there are sort of 5 categories I'm going to talk about here. So the first one I'm calling partial descoping. So that's where a project's not being able to achieve what it was meant to because it was overrunning in cost or time, and effectively the output had to be reduced in order to stay within budget. So that's actually quality not happening as a symptom of another reason. Strategic misalignment is my second category. That's where a project does what it's supposed to, but in fact the full benefits can't be achieved because other projects would have had to have been done that weren't. So you've really only got part of the full setup that you need. Technical incompatibility, another category where things just don't work technically, despite all of the resources and the skills that you've deployed on the project. There's demand shortfall, where you've built what you want to build, but just nowhere near enough people were wanting to use it as you anticipated. And then finally, of course, there's wider impacts. Often transport projects are invested in because people are looking for a social outcome. There's a lot of talk about levelling up at the moment in British politics, and so we'll come back to that a bit later on. So example of a project where it was a partial descoping would be necessary was the West Coast route modernisation, which was the big railway project if you think back about 20 years. So looking back to the 90s, most of the trains that travelled on the West Coast main line from Euston up to Birmingham, Manchester and onto Scotland were similar to this. They were electric locomotives pulling unpowered cars, speed of about 110 miles an hour, so not quite as fast as the East Coast main line at the time. And because of this low speed and difficulties in fitting in local services alongside long distance services, the West Coast route modernisation project was initiated to allow the deployment of the trains that now run on that line, these Pendolinos that you'll remember Virgin ran for many years and are now Avanti's taken over the franchise. So what you were looking at there was initially they were hoping to be able to bring in a more advanced form of signalling, in-cab signalling, where the driver gets lights within the cab, which it was eventually decided is what you would need to be safe if you were travelling more than 125 miles an hour. And the Pendolino trains, in theory, can travel at 140. Also, they would need to be able to tilt to go quickly round corners, which the Pendolino and one of the other types of trains, something called a Super Voyager, which travels on the same line, can. And so the actual infrastructure itself, though, needed to be upgraded to be able to accommodate these new trains. So the project was originally initiated just after privatisation back in the late 90s, but as you can see there, the estimated costs began to escalate very rapidly, and this is actually in constant prices as well, 2005-6 prices, and you can see this was going to be costing 7 times as much as it originally planned. actually in May 02 when I joined the railway industry. I don't take any personal credit for the fact that the estimated costs came down after that. This was partially achieved by descoping the project. The in-cab signalling had to go. We're really only in the course of phasing that in now. The tilt mechanism only is turned on sort of in the southern part of the route mainly. I don't think it's used in say Cumbria, so which was one of the areas they were hoping to be able to travel through a lot more quickly as a result of bringing this in. So in the end, the 140 miles an hour was abandoned, and the trains run at 125. So they did get the costs under control eventually, but at the cost of descoping. Now, in terms of projects where there's a strategic misalignment, one of the projects I worked on both in strategy and risk and value at Network Rail was this what's called the Great Northern Great Eastern Joint Line upgrade. So that's an alternative route for freight between Peterborough and Doncaster. You'll see there on the left that Peterborough and Doncaster are both on the East Coast Main Line, and in order to allow more capacity for fast passenger trains from King's Cross to Scotland, it was decided that we really needed to get freight off that line. So an alternative route for it is up through Lincoln instead. So coming up from Peterborough, going through Spalding, Sleaford, Lincoln, and then rejoining the East Coast Main Line at Doncaster. This required an awful lot of work on all aspects of infrastructure, tracks, civil engineering, bridges, tunnels, signalling, etc. Between Warrington Junction, which is where the Great Northern Great Eastern Joint Line splits off from the East Coast Main Line, all the way back up to Doncaster. Again, now this project was completed after some major risks, which I don't really have the time to go into here. It was badly affected by a slip in the spoil heap at a colliery somewhere near Doncaster, which took out another railway and meant this had to be used as a diversionary route for a while. So this project did take a lot longer and cost a bit more than was expected. The main problem with it, though, is that you don't really get the full benefits unless you also improve Warrington Junction. So this is a diagram of Warrington Junction, and you can see one of the problems here is that a train heading north onto the joint line to Spalding would have to cross all of the lines of the East Coast Main Line in order to get there if it had come in on this freight line at the south end here. So you'd be crossing all of the other lines, reducing the chance to pass trains through them and eating into the capacity. So you couldn't really get the full benefit of the GNGE project until you'd upgraded this other one. And although the GNGE project finished 6 years ago now, I distinctly remember attending the project completion party. Warrington Junction's only just been done earlier this year, and any of you who've been travelling on the East Coast Main Line may have noticed absolutely loads of work going on just north of Peterborough, and that was this. So we've had a 6-year period where you've not really been able to get the full benefit until this new tunnel has been put in underneath underneath the East Coast Main Line, which was a major bit of civil engineering. Similar problem we have in the middle of Manchester at the moment. I think a few people who may be on this call have worked on the Ordsall Cord project, which was to allow a new route from Manchester Victoria to Manchester Piccadilly stations, which you couldn't go to directly without doing a funny reversing move at Salford Crescent before. So this was a very successful project and finished approximately on time and in budget, and people involved were praised for it. But unfortunately, it's got a problem with the wider context. The idea of the Ordsall Cord is that trains can travel from Manchester Victoria round this new bit of track and then come into Manchester Oxford Road and Piccadilly. But what's happened is that really we've just added another 2 trains an hour into what's already a very highly congested bit of infrastructure in Manchester. So you can see there the Ordsall Cord has allowed these 2 new trains per hour to come in from originating in Newcastle and Redcar up near Middlesbrough, but that's adding on to 12 trains an hour which already exist, and now the the infrastructure is just congested, and there's been a lot of problems with train performance around Manchester. So we're now really at Transport for the North in the process of trying to work out what the solution to this problem might be. So that's sort of strategic misalignment problems. Other issues are where you have technical difficulties. Now this takes me back to what was one of the most difficult parts of my career at Network Rail, which was the Hendy review. When the current chairman of Network Rail, Sir Peter Hendy, was appointed, he asked us to go and look at some of our risk registers again for projects that we'd already done, and quite a few other ones. About half of the projects listed on this page, which he asked to be looked at again, were ones which I'd originally been the risk manager for. And so I thought, well, okay, I'll go back to the project team, see if there's anything we've missed the first time. This was sort of in the second half of 2015. And it turned out that actually a lot of the engineers on these projects had been maintaining their own separate risk registers, which had what they were calling the real risks on. Now, this unfortunately goes back to perhaps to my enthusiasm for the cost and time modelling aspects of project risk management. They thought that we in project risk and value management were only really interested in the cost and time risks because that's what we spent all our time modelling, and they kept the real risks, the chances that the projects just wouldn't work, to themselves, and they were maintaining their own separate risk registers. So that was quite a stressful time. You know, included lots of things to do with electrical engineering, which, not being an electrical engineer, I didn't really understand. But they were saying, well, yes, there's a chance this new bit of kit, this substation or bit of cabling, it won't actually work, or it'll cause electromagnetic problems and things. So that was quite a difficult time, and some of these projects, I think, were delayed while they were trying to sort those problems out. About 9 months after this, I actually left Network Rail and went to work in WSP, but found out that, to my surprise, 6 months later, I actually was seconded back into Network Rail again. And ended up going down to Paddington and working on the Great Western route modernisation. So same sorts of issues, different part of the country. And in fact, I found out these technical problems there were, if anything, a whole order of magnitude worse than things I'd seen on the East Coast Main Line. Now, the purpose of the Great Western route modernisation project was to replace these old workhorses, the British railway system, the old Class 43 locomotive going back to the 70s, to allow the network to be electrified in some places, and the trains replaced with these new bimodal trains. So hopefully those of you who travel by train, and if you travel on TransPennine Express or LNER or Great Western, you'll have travelled on one of these, the Hitachi Class 800 series, some of which can travel under both diesel and electric power. And again, under the electric version, in theory, they could travel at 140 miles an hour, but this particular model, the Class 800, can only travel at 100 under diesel power, and that's relevant to one of the problems they were having on the Great Western route modernisation project. So if we look at a map of the area, you can see the main line from Paddington through Reading to Swindon, and then on to Bristol and Bath, and then Cardiff and Swansea. That was meant to be electrified. And then trains that travelled on beyond Bristol down to the southwest could do the rest of the journey on diesel power. Now, unfortunately, it was found out that because these trains are actually bigger than, in the sense of being slightly taller, slightly wider than the trains that they were replacing, when they were travelling on electric power, they were actually causing electromagnetic interference with the signalling system. Which was meant that basically they couldn't operate, and there was a period when they had to sort out this problem. And in the interim, the suggestion was all the trains would have to travel on diesel power while they were sorting out this electrification problem. Now, as I said, unfortunately, on diesel power, these trains can only travel at 100. and the trains they were replacing, the Class 43s, could travel at 125 miles an hour under diesel power. Now, those of you who know a bit about railway timetabling probably realise that if you're trying to mix different trains together travelling at different speeds, you actually can run fewer trains, because a train travelling at a lower speed, which would be the red one on this distance time diagram. So if you remember your maths at school, the gradient of a line on a distance time diagram is the velocity of whatever it is you're measuring is travelling at. This slower train, number 5 here, is eating up capacity which you could have actually fit several faster trains into. So on the Great Western Route Modernisation programme, they were faced with the problem where, after spending billions upgrading the railway, they were going to be able to run slower trains and fewer of them, which was looking to be a major embarrassment in 2017 when all this was happening. Now you may think, well, why not just delay bringing in the new trains and keep the old trains in operation? But unfortunately, that's where there were political problems came in. And in fact, we'd already signed a contract with the Scottish government saying that these trains were going to be heading up to Scotland in, I think it was October 2017. So there was no option to just delay things a bit. So it was all it was what we would call in risk management circles a wicked mess. And I think a few of you may have heard of David Hancock. He's one of the most famous project risk managers in the country, and he came up with this categorization of how, if you have different numbers of stakeholders, so that's your political and organizational issues, and then technical issues on the x-axis here. If you have problems with both the number of systems and the number of stakeholders, your project can get into a wicked mess where you both have these technological and political problems. And I very much think that's what happened with Great Western Route Modernisation. The next category of problem I've come across is demand shortfall, and I think this is an area where the issue of optimism bias is very salient. Now, I think this book, Mega Projects and Risk, is one of the most famous ever written in the field of project management. Certainly, I remember my old boss at Network Rail, Jeremy Harrison, who was well known in risk management circles, recommended it back when it was originally published, and I was working in his department. And Bent Fugberg, Danish social scientist, was looking at the big bridge projects that connect Denmark to Sweden and the different islands of Denmark together, and why they'd all ended up costing a lot more than was originally planned. And he talks about the issues of optimism bias a lot, and how there's a pressure to be over optimistic about what things will cost, coming from often from the sort of the political sponsors of projects. But we've tended to find that in the railway industry as well. Some of my colleagues have actually studied optimism bias in concert with academics. So this table here is from a bit of research that was done by Jeremy Harrison, in fact, and some academics, I think might have been from University College London, who were looking at how much costs escalated during the course of railway projects. So these things you can see here: GRIP 1, GRIP 2, GRIP 3. For those of you who don't know, GRIP is Network Rail's project management process. It has 8 stages until you eventually close out a project, finish off all the finances. GRIP 6 is where you actually go and build whatever it is that you're doing. But during the development stages, GRIP 1 to 5, typically costs would escalate from the original estimate by in the region of 66%, and that was what we were adding on back in the early noughties to the first estimates that people would come up with for how much projects were going to cost, in order to actually come up with a real estimate of what the eventual financial output would be. And actually, about 5 years ago, Jeremy and a few of other colleagues from Network Rail tried to refine this a bit more and look at whether there was a difference between renewals and enhancement projects, between simple and complex renewals and enhancements, and whether the figures should be changed a bit. But the general theme is that, no matter what type of project it was, there tended to be a big uplift between the very first estimate that anybody came up with and the eventual cost. And this is what we were calling optimism bias. Now, the thing is, though, and what Bent Fluberg looked at, is that optimism bias doesn't just relate to the costs of projects. It often relates to what the benefits are. In transport projects, the benefits generated by a project are pretty much directly proportional to the number of people who use whatever bit of infrastructure it is you build. And equally, these are often very over-optimistic forecasts. So looking there at this table from Bent Fluberg's book, the Humber Bridge, quite near me in Yorkshire, cost almost 3 times as much as it was originally intended to, 175% overrun, but in many ways worse, got only 25% of the forecast traffic in the opening year. And so in some ways you could that's almost as bad as like a 12 times cost overrun, because if something costs 3 times as much but only gets a quarter of the people using it, it's almost you could multiply those two out really to measure how off you were with your business case for building it in the first place. But as you can see, that's not unique to the Humber Bridge. Channel Tunnel took a very long time to get the numbers of passengers that were originally forecast. In fact, I think it's only just before the pandemic getting up to the sort of numbers of passengers that people thought would use it within a few years of when it was originally built. So yes, you have this problem with demand shortfall as well, and then it has revenue implications. You don't get back the amount of money that you've invested. And we do have a bit of a problem with this in the railway industry, in that the numbers of passengers who use railway stations are often quite different from what was originally forecast. And you can see there, although we've had somewhere such as Ebbvale Parkway in Wales, where they got over 5 times as many passengers as was forecast, quite a few of the stations that have been built in recent years have only got about 50% of the numbers of passengers that were forecast. So this is an area where you can have optimism bias as well. And then the final sort of quality or function failure that I've come across is where the wider economic impact doesn't materialise. So a lot of the transport projects in Britain are currently being marketed as intended to level up the economy and close the north-south divide. I think when High Speed 2 was proceeding through Parliament, they were particularly impressed by this paper that the Department for Transport wrote, High Speed Rail, back in March 2010, just before the change of government, showing that basically the longer it took to get by rail from London to somewhere, quite often the poorer that area's economy was, and there was the feeling that if you just made Britain more integrated through rail travel, you could boost productivity, or how that's measured here, gross value added per head, in some of the poorer areas of the country. So that's the theory of levelling up through transport and high speed too. There's also just the fact that the southeast was getting vastly more investment in transport at this time. So there you can see this is from the Institute for Public Policy Research, which is the Labour Party's think tank. So going back about 10 years, they'd measured recent investment, or investment that was planned at that time anyway, in transport, and found that London was getting a huge amount. That London in the southeast, which has a population of roughly 20 million, was planned to get 35 billion of transport investment, whereas the whole of the north, which so northeast Yorkshire and the northwest, which has a population of about 15 million, was only getting about £2 billion worth of planned transport investment. So this was very much leading to the theory that investment in transport would help close the north-south divide. Now, in practice, in history, this is quite questionable, really. This table is from a report done by a think tank called the New Economics Foundation. It's available freely online, but they were talking about how high-speed rail has impacted the economies of places like Japan and France that have it. And in France in particular, they noted that actually Paris seemed to gain more when the TGV was first installed in the 1970s. That previously a businessman going from, say, Paris to Lyon would stay in Lyon overnight, spend money in the hotels and restaurants, and then go back to Paris the day after. But once you could do it comfortably in a day, it actually reduced the money being spent by Parisians in outlying areas, and so it, in some ways, had the opposite impact of what was expected. And so, of course, the skeptics would say that that may well happen with high speed too, as well. So the question is then, what can we do about these sorts of risks? And in the remainder of the talk, I've just got a few examples of how you might go about addressing quality risks within the project risk management process. Collectively, these are often called the left shift in project management, and both specifically project risk management. How do we identify risks that might scupper our projects earlier on? And this is an example of the left shift from an old issue of project. The main way to do it really very much is think of the business case phase of a project, or the development stage, as a project in its own right. So this is one thing that I found working in project risk management at Network Rail. Project teams sometimes were quite difficult to get their heads around, that if you sat down and asked them what were the risks on a particular project, they would jump straight to the risks that would happen during implementation. Finding poor ground conditions and things like that. And really, you need to think about the risks that will stop your project even getting off the ground by not getting together a business case. And the business case process sometimes involves a bit of outline design so that you can estimate how much the costs are going to be. So that feeds into the optimism bias aspect of your cost estimates. But also, it involves looking at demand forecasting and so on. So you've got to be careful about the errors that might creep in on that side of things too. Now, in the transport industry, we actually have to use what the government's official methodology for making a business case, which is laid out in something called the Treasury Green Book, which you might have heard a bit about in the news recently, where there's 5 parts to a business case. You have to both you have to demonstrate that it's what's called a strategic case for the project. I mean, why do we actually need to do something? What needs to change? Demonstrate that the economic case, i.e. that provides value for money, that the benefits will be worth the costs. Is it commercially viable? Will you be able to sign contracts for people to build and operate whatever it is you want to implement? Where's the money coming from? The financial case, can we actually fund it? And then do you have the ability to actually project manage this and deliver it? And that's where you might look at things like the showstopper risks that will just stop the project happening at all. You've got to address all of these in not just transport, but in any government project at the moment. And so in a project business case, you might be looking at demonstrating that you could pass all of these areas. So this is just an example of a road project that somebody was using in Amy to show how you could actually sort of fit one of these 5 case model business cases on a page. But yeah, you'd have, well, how much is it going to cost? Very good benefit cost ratio here, actually 3.2, which is suggesting you're getting 3 times as much benefit as the cost. Details about how they intend to actually implement it, and why do we want this road, reducing congestion, building the economy, allowing housing growth. So clearly, if you're building new housing estates, you have to think about how people are going to travel there. Now, in my experience working in the transport industry, we don't think about risk enough at this stage of projects. Yes, you have to do a cost risk register for the financial case, Yes, you have to do an overall risk register, including showstopper risks in the management case. And so generally I find these in business cases for transport projects. But we don't think enough about the strategic risks, and that's why I think things like these misalignment risks, do you need another project doing in order to achieve what you want to, perhaps not addressed. The economic risks, well, the cost side of the economics comes in through the financial risk assessment, but there's probably not enough thought given to the demand shortfall side of it. Are your models of how many people are going to use this transport infrastructure enhancement accurate, which we'll come back to in a moment. And commercial, well, they sort of think about commercial risks because you have to think about who's going to bear them between contracting parties, who's going to pay if there's a cost overrun, and so on. But overall, I think we don't do this thoroughly enough, and probably, ideally, I think there should be a risk register in all 5 parts of the business case, looking at all the different types of risk, not just the cost overrun risk, which people are most comfortable with. I should point out that those risks I've just been talking about are risks in the business case. There's also the problem of risks to the business case, which is there anything that's going to happen during your modelling and analysis which will throw you off? And I'll just say, unfortunately, several times in my career, we've had projects delayed a bit because they left computer models running overnight, and somebody came and pulled out a plug to plug in the vacuum cleaner or something. So there's risks to the business case as a project in its own right as well. So thinking along sort of modelling and so on, I think this is an area people could take a little bit more interest in within their own industry, because you may think if you're a project risk specialist or a project manager that stuff like transport modelling is a bit beyond you and you best leave it to the professionals. But if you want to challenge people who are building the business case, it's easier than you think, actually. I'm addressing this particularly to risk professionals. There are ways of actually verifying whether models are correct and are an accurate reflection of reality. So looking here at an example from what's called a Saturn model, this is what is used for road projects. They generate maps which show how people might travel through a town. So this particular map from a Saturn model shows how people might travel from Birkenhead, so coming through the Mersey Tunnel, and head off towards St Helens. And under this model, it's suggesting 97% of people would travel right through the middle of Liverpool, whereas 3% of people would try and be clever and arc up through a different route to the north of the city. And if you were doing a project in Liverpool, you might look at ways in which improving the roundabouts or increasing the number of lanes on the alternative route might take people out of the city centre. But you can actually check these models against reality, because we can now, using satellite data, actually look at how people making particular journeys do in reality use routes. So this is from a WSP report on some traffic improvements around Shrewsbury, and you can compare a Saturn model to data from Google to see whether it is actually accurately modelling what people are doing. So you don't really need to know all the ins and outs of how something like a Saturn model works in order to be able to challenge them. Similarly, traffic models of individual crossroads or roundabouts these days often produce graphics. This is Siemens traffic modeling system, Vissim. And I know that some things people do to assess the validity of the models is actually compare the graphics to video footage of the roundabout or the intersection, and then you can check whether the models are an accurate representation of reality. So as a risk professional, you can always challenge whether people are doing that sort of thing. And again, on the economic side, you'll often hear people say that, oh, if we improve transport links, it'll improve job opportunities. But you can challenge these sorts of models with common sense as well. So here, for example, is what are called isochronal maps of the the Scottish Borders rail reopening, which was successfully completed a few years ago, running south from Edinburgh into the Borders country. And this is in particular is showing how if you lived in this town of Eskbank on the border of Edinburgh, you could now within 90 minutes maybe commute to a job in Falkirk or something. But all this relies on the assumption that there are businesses in Falkirk that actually want to employ people who've got the skills that the residents of Eskbank have got, and sort of general economic models might really not cut the mustard. So again, as a project manager or risk professional, you could just delve into these things, challenge them a bit more, and try and maybe avoid some of these wider benefits risks. Final example of modelling here is a lot of models these days rely on feedback loops. So this is sort of the cutting edge of computer modelling, illustrated simply here with the two great questions of philosophy: which came first, the chicken and the egg, or why did the chicken cross the road? So in the feedback loop models, the more eggs you get, the more chickens there are. The more chickens you get, the more eggs there are. So that's a reinforcing link. But at the other side of things, the more chickens there are, the more road crossings there are. But if you have more road crossings, fewer chickens come back. And you can use these sorts of techniques to model really complicated situations. So this is an example of what we call a transport land use interaction model, looking at availability of land, where people might build houses, how this then impacts on demand for transport and so on, commuter trips and so on. This is the sort of thing we would use in Transport for the North for modelling the benefits of major transport interventions. But you can challenge the assumptions behind any of these feedback loops in models like this. The other way of getting quality in, which I just want to mention briefly at the end here, is not so much in the business case, but is in the value management process. So I say at Network Rail, we had to do risk and value management together, and value is defined as basically what you get for what you give. What is the benefit for the cost that you were incurring? And this was something we had to do alongside risk management. At Network Rail, there was a 4-stage value management process. Later on, you looked at value engineering and using the best types of materials and so on to cut back on costs without affecting the output too much. But earlier on in the value management process, you would use all sorts of tools, fast diagrams and so on, to analyze why are we actually doing this project. And this is an area where you can work the quality risks in and make sure that they're taken account of. So a fast diagram, hopefully a few of you have already seen this, but this is where you break down the overall aim of a project into its component parts. And so you can actually then read back why we are doing things. If you read the graph from right to left. So why are we adjusting the signalling? Well, because we need to alter level crossings. We need to alter level crossings because if we would have to for safety reasons if we have twice as many trains. We need twice as many trains because they're overcrowded. And then easing overcrowding will make journeys between York and Harrogate easier. And you can see how a whole project fits together using a diagram like this. And this allows you to identify the risks. And Network Rail themselves appreciate that, and in their sponsors handbook, they made this rather interesting diagram where they point out that a project which is well defined but badly delivered will still probably achieve more than a project that is poorly defined but well delivered. And a lot of organisations combine project risk and value. And this is a way that you can actually look at the quality risks as part of your risk management process. And obviously this slide here shows you the organisations which, to my knowledge anyway, do have combined risk and value teams. Final little example then of a quality risk, which is topical and we'll hear about in the next few weeks, is looking at Transport for the North's aspiration to have a northern powerhouse rail network which connects the 6 major cities of the north of England. and Manchester Airport. And a big decision that is going to be made very shortly is whether this route, the route between Leeds and Manchester, will go via Bradford or via Huddersfield. That's shown on this diagram here, where we've got this the sort of the light green line is the possible route via Bradford. The other alternative is to go via Huddersfield using the existing Transpennine route and just try to upgrade that. Now, in my opinion, if you want to avoid a quality risk, the thing to do is go via Bradford, because at the moment the Bradford route is very slow. It takes about an hour and 20 minutes to get from Leeds to Manchester via Bradford, as opposed to less than 50 minutes going via Huddersfield. So if we choose the Bradford option, then we've transformed the rail geography of the north, and we've brought Bradford into the centre of the rail geography, which will be a big economic boost for Bradford. Whereas if they go via Huddersfield, all you're doing is basically getting a faster journey to a route which has been getting progressively faster for the last 50 years anyway, due to progressive enhancements. So if we advertise the purpose of Northern Powerhouse Rail is to get the Leeds-Manchester journey time down to 30 minutes and we only get it down to 35, people might say, well, you didn't really achieve what you wanted to, was it worth it? Whereas if we go via Bradford instead, then we've reconfigured the rail geography of the north of England, and we'll definitely have a big economic impact on Bradford, I think. So the choices you strategically make ultimately are going to determine your quality risks, and that's where I'll leave it.
Thank you very much, David. We have got a few questions, but if you'll indulge me, I might start with one of my own, if that's okay.
Yeah, sure. Yeah.
Right back at slide 7, where you had the cost time quality triangles.
Oh, right, yes, yeah.
But one of them had an F. Now, time quality and F, I assume that's function.
Oh, right, yes. Function, yes. You can. That particular article used function to be the same as quality, really. I mean, I think the definition of quality that people often use is conformance to specification. Does it do what it's supposed to? And so I think, yeah, I think function is the term that's used by value management professionals to mean the same thing. Basically, does this do what it's meant to do?
Okay, Ashok had one also on slide 7. He's asking about 2/3 up on the initial price and talking about business cases being simplistic. I'm not sure if we can whiz back to slide 7.
Oh, right. Well, yes, I suppose I could do. Yes, let's see.
Yeah.
Gosh, so it was around. Let's see. There we are.
So
roughly that area.
One. So 2/3 up on initial price. So I assume.
Was that slide 7 or was it later on? I think. No. He was talking about the cost overruns, wasn't he? Which was here. Yeah. Yes. The 66%, which they add on for, it was 66% then, it's still 64% today, actually, after the result of this research, which was submitted to the Department for Transport. I think they were originally hoping they might have different percentages for renewals and enhancement projects, but in the end, the DFT just decided to change the 66 to 64%. So not a huge change.
And the other one I have, and this is purely out of interest, is on slide 19, which is, it refers to the great face covering debate about trains. Now, I looked at that slide and thought, is that to do with the paintwork on that train?
Oh, right. Yes. I think actually this was before that, wasn't it? It was, right, yes. That was actually, yes. You'd have to get a copy of Modern Railways from last August. Yes, it was. This was obviously from quite a recent, relatively recent article, and they were discussing, whether people should be forced to wear face masks on trains. It was still an issue then because demand was briefly recovering last summer during the pandemic. I think everybody's in agreement now, though, that we do have to wear face coverings on public transport for the foreseeable future.
Mhm. Have we got any more questions? I've only had those ones in from Ashok we've covered. Have you seen any more coming in, Rob? Oh, there we go. One from Robert. Are many programs performing integrated cost and schedule risk analysis? And if so, is it providing better accuracy?
Right. Well, yes, that's an aspect of Bent Flueberg's work which I haven't covered in this talk. It does tend to be the case that projects that overrun time-wise are also the ones that overrun in cost. And if you can manage your schedule better, you should be able to keep costs down, because of course a lot of project costs are just fixed and will extend in proportion to the duration of the project. Now, in my experience in risk analysis, we've not done that. I've not come across anybody who's been doing integrated cost and schedule modelling. In Network Rail, we have the tools. In PertMaster, you can do integrated cost and schedule modelling. I mean, I think I did it once as a sort of experiment. I think I remember now on looking at Huddersfield Station, actually in the early stages of TransPennine route upgrade, but I don't think there was a demand for it from project teams, and that is a bit of a problem, because if you just look at if you look at cost and schedule modelling separately, I don't think that's an accurate reflection. So I think this is an area where, yeah, it would be great if risk professionals got a bit upskilled and used the tools to their full capacity, and we did do it more.
Okay. If there aren't any other questions, there are a few questions on there which I'm sure Rob can answer for us about copies of the slides. Now, here's one from Ashok again. What's David's view on Elon Musk's Hyperloop? Have you thought about what showstoppers they may encounter?
Right. Okay. Now that's interesting. You should mention it, because this is in some ways actually going back to slide 7 again, when I was talking about High Speed 2 and it being a project where time was more important than cost, maybe, because there is the issue that if things take too long, they may become technologically obsolete in the time frame. Yeah, if we said that High Speed 2 wasn't going to be built till 2045, people might say, oh, well, by then, someone like Elon Musk will have made Hyperloop work and make it more feasible, and the railways would be obsolete, really. And I think that I'm not an expert on Hyperloop, but as a general observation, I think, yeah, the chances are, if you're looking 20, 30 years in the future, technology may have moved on in such a way that the business cases for things we're building now will be overtaken by events. I remember recently I was watching a documentary filmed in 1970. Narrated by Orson Welles, so going back a long way when he was still alive. But it was about the futurology book Future Shock by Alvin Toffler, which I think some people will have heard of. It was very popular about circa 1970, and this guy Alvin Toffler was making his predictions for what changes he would have thought would have happened by the end of the 20th century, and looking at the predictions that he made, yeah, a lot of them hadn't actually happened by the year 2000, but they are happening now. So I think technology sometimes takes a little bit longer to be perfected and to come in than its proponents expect, but it does get there eventually. So my instinct would be that yes, in 20 or 30 years' time, it may be that current transport technology is obsolete, in which case building business cases around 60-year lifespans and things might be a bit unrealistic.
Okay, a few more have come in. From Robert, is there an overall integrated DFT transport strategy for all modes? So motorway, bus, tube, rail, plane, or is it done individually by mode?
Actually, that's a good question. I mean, the documents I'm aware of do tend to be by mode. So yeah, we've just had the rail white paper, which was in the news a couple of weeks ago, which I was writing Transport for the North's response to. A few months before that, we had a national bus strategy, and I'm aware you do get similar aviation strategies and so on. Is there an over? Yeah, I think there is at the analytical level, in that the Department for Transport does have models of the whole transport situation in Britain, and if you and looks at how air and rail are in competition with each other, and how road and rail are in competition with each other for certain journeys. So for sort of journeys of about 100 to 200 miles, road and rail are in competition. Sort of more than 300 miles, it's air and rail that are in competition. So they do assess proposals with multimodal analysis. They've got something called the Planet model, which looks at all long distance journeys. But there may be a national transport strategy, but I've not had to use it or refer to it in any analytical work I've done. It's just individual modal strategies which tend to be publicised.
Okay, one from Jitendra. With the new rail project speed initiative, is there an aspiration of reducing both cost and time on projects? And is there an approach without impacting quality?
Yes. Now, I think there is a risk you could have a quality impact, because they're trying to shorten projects by cutting down on all stages, including the development stages. So my understanding of what Network Rail are doing is that they're replacing GRIP, the Governance of Railway Investment Projects, with something called PACE, which also stands for something. I think it's something Projects Accelerated in a Controlled Environment. And then SPEED is an attempt to change the culture of Network Rail. So PACE is the actual sort of bureaucratic tool. SPEED is the culture change, to try and have fewer sort of stage gate reviews and these processes which could slow things up. And I'm not close enough to it to know exactly how they're going to do this, but I think there is always a risk of more quality risks slipping through, because as I was saying, what I'm interested in promoting is this idea of the left shift, that we should spend more time thinking about things early on, so that we don't get towards the end of the project and realise that we could have done things better. In fact, I think there was an interesting example on this, was the project I talked about, which was the GNGE project. If I go back to the slide there. Now, this project was, as I mentioned when I was talking about this, was delayed. Well, it was delayed anyway. I think it was over time and over budget anyway, when they had this colliery spoil heap take out a whole railway in the vicinity, which meant that they had to stop while this railway was being used as a diversionary route to replace the railway near Scunthorpe, which had been demolished by this landslip. And actually, while the project teams were forced to down tools on this project, they thought up ideas for how to do the remaining work in a more efficient way. And although this colliery landslip delayed time-wise the completion of the project, they felt that the cost impact of this sort of disastrous, unforeseen risk was positive. They actually used the time to think how to do work more cleverly, and it was one of the reasons that in the end it was seen as a fairly successful project, when it could quite easily have just been remembered as being massively over time and massively over budget.
A couple of others from Tom has around health and safety. So how is health and safety factored into the time, cost and quality triangle in Network Rail?
Right. Well, that's yes, that's very much on the quality side of things. That there are standards which are quite rigorous, which you simply have to meet. If you're looking at things in terms of building the business case for something, that things like health and safety are very much in the management case side of things. So can we deliver this project in a safe way? Do we have the people who've got the skills, and do we have a track record of being able to deliver things in a safe way? I mean, while I was at Network Rail, as I haven't actually worked for Network Rail for 5 years now, there was quite a big improvement in workforce safety. I think in the early years when I was there, about the turn of the century, I don't think anybody thought you would ever get to the point where you would have zero workforce fatalities in a year. There was a sort of reluctant acceptance that it was construction was dangerous work, but the leadership at Network Rail really did lead a culture change that meant that before I left, we did get down to the point where there were several years when there were no workforce fatalities at all, and that was something which would have been regarded as very optimistic back about the turn of the century.
My last one from Asher. With the COVID virus, it got itself in here as well. It's terrible. Do you think the capacity estimates now need to be reduced because we've realised that Zoom, etc., is quite effective?
I think the answer is yes. Just the question is how much. Really, what level will rail demand stabilise as a proportion of pre-COVID demand? I would have thought somewhere in the region of, I would optimistically think at most it would be 90%. It could be as low as 70% possibly. I mean, I'm not pulling those figures off the top of my head. I've been sort of party to a lot of communication between different bodies about that. They've all got their own estimates. That's just my attempt to summarise what the general thinking is. However, I would say that one thing that people maybe don't realise is that commuting is only sort of the most important market in the London area, where I think 50% of rail travel is commuting. The rest of the country, leisure purposes, so not commuting or business travel, is the main reason that people travel. And in most of the markets that I deal with in transport for the north, it's 70-80% of journeys are actually people travelling for leisure. So in fact, they may get back to where they were after COVID.
That's brilliant, David. Well, that's the end of the questions I got. So I think all that remains now is probably to say thank you very much for the presentation, for answering everyone's questions, and to say thank you for our attendees for coming along and paying attention and listening to what needed to be said, and for asking questions.
Yeah, thank you.
If there's no more from anyone else, a few thank yous coming in now, so that's good. So I think we can close there. So thank you, everyone.